Hello everyone, my name is Manideep. Hello everyone, my name is Manideep. I am from CSC AML B section. Today I am going to say about the how to improve the quality of object oriented programming. As as the name suggested that object oriented programming or OOPS refers to languages that uses the object in programming. Object-oriented programming aims to implement real-world exam entities like inheritance, hiding, polymorphism, abstraction, etc. in programming. The main aim of object-oriented programming is to bind the data together and the functions that operate on them so that no other part of the code can access their data except that function. OOPS concepts includes the attributes like classes, methods, functions, data, data abstraction, encapsulation, inheritance, polymorphism, dynamic binding, message passing. Class. A class is a user-defined data type. It consists of data members and member functions, which can be accessed and used by creating an instance of that class. For example, consider the class of cards. There may be many cards with different names and brands, but all of them will share some common properties called blueprints. Here the blueprint is the blueprint of the object is called class. Object it is a basic unit of object oriented programming and represents the real life entities. An object is an instance of class. For example, dog is a real life object which has some characteristics like color, breed, bark, sleep, and eats. Data abstraction. Data abstraction is one of the most essential and important features of object-oriented programming. Data abstraction refers to providing only essential information about the data to the outside world, hiding the background details or implementation. Encapsulation. Encapsulation is defined as the binding of the data under a single unit. It is the mechanism that binds together code and that data it manipulates. Inheritance. Inheritance is an important pillar of OOP. The capability of a class to derive properties and characteristics from another class is called inheritance. Here we use the calling function or call by value to follow the inheritance. Polymorphism. Polymorphism means having many forms. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. For example, a person that at the same time can have different characteristics, like a man at the same time is a father, a husband, and employee. So the same person possesses different behavior in different situations. This is called polymorphism. The fundamentals of OOPS are understanding the principles and concepts of object-oriented programming is crucial for achieving high-quality code. Emphasizing encapsulation, inheritance, and polymorphism leads to robust and maintainable systems. Design patterns. Exploring design patterns is essential for crafting elegant and efficient OOP solutions. Utilizing patterns such as singleton, factory, and observable enhances the flexibility and reusability of code. The design pattern is an essential element in object-oriented programming. It is a software infrastructure made up of a small number of classes that is used to solve a technical problem. Testing strategies. Comprehensive testing strategies are vital for ensuring the reliability and stability of OOP code. Employing unit testing, integration testing, and mocking fosters a culture of quality assurance. Refactoring techniques. Mastering refactoring techniques empowers developers to continuously improving the clarity and maintainability of OOP code. Embracing code smells and applying refactoring patterns elevates code quality. Refactoring is the process of changing a software system in such a way that it does not alter the function of the code yet improves its internal structure. Dependency management. Effective dependency management is pivotal for crafting modular and cohesive OOP systems. Leveraging dependency injection and inversion of control fosters loosely coupled and testable code. Performance optimization. Striving for performance optimization is paramount in achieving unparalleled quality of OOP. Balancing efficiency and scalability while minimizing resource utilization is a key focus area. Security considerations. As we can observe that in OOPS, there is no more security or more data hiding than in procedural languages. Because in OOPS we have that we use that access specifiers like public, private, protected, or default. But in procedural programming we there is no access specifiers. So in OOPS there is no data hiding or data security. Addressing security considerations is imperative for safeguarding OOP systems against vulnerabilities and threats. Implementing secure coding practices and encryption techniques fortifies system integrity. Documentation, documentation standards. Adhering to documentation standards is essential for fostering clarity and comprehensibility in OOP projects. Clear API documentation and code comments are indispensable for seamless collaboration. Continuous improvement. Embracing a culture of continuous improvement is a vital for sustaining unparalleled quality in object-oriented programming. Encouraging feedback loops and iterative development fosters a mindset of perpetual enhancement. Best practices recap. Recapitulating the best practices discussed is crucial for internalizing the quest for unparalleled quality in OOP. Embracing this principle will lead to exceptional code and sustainable systems. As we can see that in security considerations, once once again we can revise the testing strategies. As information systems are becoming more complex, the object-oriented paradigm is gaining popularity because of its benefits in analysis, design, and coding. Conventional testing methods cannot be applied for testing classes because of problems involved in testing classes. There are more problems in testing classes, abstract classes, inheritance, dynamic binding, message, passing, polymorphism, concurrency, etc. Testing classes is a fundamentally different problem than testing functions. A function or a procedure has a or a method has a clearly defined input output behavior, while a class does not have an input output behavior specification. We can test a method of a class using approach for testing functions, but we cannot test the class using these approaches. Data dependencies between variables, calling dependencies between modules. But an object-oriented system, there are following additional dependencies: class-to-class dependencies, class-to-method dependencies, class-to-message dependencies, etc. Issues in testing classes. Additional testing techniques are therefore required to test these dependencies. Another issue of interest is that it is not possible to test the class dynamically. Only its instances, that means objects, can be tested. Similarly, the concept of inheritance opens various issues. If changes are made to a parent class or superclass in a larger system of a class, it will be difficult to test subclasses individually and isolate the error to one class. In object-oriented programming, the control flow is characterized by message passing among objects, and the control flow switches from one object to another by inter-object communication. Consequently, there is no control flow within a class like functions. This lack of sequential control flow within a class requires different approaches for testing. Furthermore, in a function, arguments passed to the function with global data determine the path of execution within the procedure. But in an object, the state associated with the object also influences the path of execution, and methods of a class can communicate among themselves through this state because this state is persistent across innovations of methods. Hence, for testing objects, the state of an object has to play an important role. Techniques of object-oriented testing are as follows, like fault-based testing, class testing based on method testing, random testing, partition testing, scenario based testing. And thank you.